You see that new movie, V for Vendetta?
Yeah, it's sick. I saw
It's
it
a
last
sick
night.
movie. You see the ending?
Which one?
Yo, the part when those two guys like get hit by those knives, bro, and they go flying.
Oh!
They go
That's not
flying.
true, man.
Oh, man,
it's
it's
not
real.
true.
It's
No,
real.
it's not real. No, let me show you.
It's a movie.
Let me show you. Well, first, the velocity of the knife is 35 meters per second, right? That's like 80 miles per hour. Come on, man. 80 miles per hour.
It's real.
And then the mass of the knife is like 1 kilogram. It's like 2.2 pounds. It's pretty straight.
It's pretty real.
And the mass of the person that it hit, 72 kilograms. He was staying straight, so his velocity is 0. And the guy moved back like 2 meters, right? After the knife hit him.
It's real.
Okay? Now I'm going to show you why it's not true
It's real.
with math. I'm going to do momentum.
Dude, it's a movie.
I'm going to show you momentum.
Alright.
Why?
MA EA plus MP EB into MA EA final plus MP B.
This is the knife, this is the person. A is knife, B is person.
Sweet.
The person is 0, its initial velocity is 0. So then this just becomes
MA EA into MA EA final plus MPB B. Now consider minus 0. MA EA into MA plus MP B. I do this because the mass of the person is MA EA. The mass of the person is the mass of the knife is 1 kilogram times 35 meters per second is equal to the mass of the kilogram is 1 kilogram plus 72 kilograms is the mass of the person. B. Combine this 1 kilogram plus 72 kilograms. 1 kilogram plus 72 kilograms. The answer I get is 35 divided by 73.
so the person at the end is traveling at a velocity of about 0.479 meters per second.
What's up, dog? Alright, I know we were kind of heated about the V for Vendetta topic, and I'm
Yeah.
sorry. I honestly thought it was real, but you proved me wrong. But have you seen the movie Wanted?
Yeah, I saw the movie Wanted.
Alright, remember the end? That part has to be real, dude. Like, that part's
Are
real.
you serious right now?
Like,
you
at the
serious
end,
right now?
embarrassing
Are you
that.
serious? No, I'm
Do
too
it
mad
again.
right now.
Let's do
Dude,
it
I
again.
can't even explain this one right now. I'm too
Again?
mad. I'm gonna give it to my friend Jonathan, right? He's gonna explain this one.
Alex, you said wanted is real. Well, I'm going to give you 2 reasons why the last scene is completely fake. The first reason is, if you were to look, like let's just take it in the simplest form of curvature. If you were to have a ball on a track, alright, the ball is going in a circle. It's just going around the track this way. If you were to cut the track right here, that ball is not going to start moving this way just because it was in a track. It's going to go tangential to the track itself, and it's going to go in like a straight line. That's the same idea that we studied in the acceleration chapter in the circular rotation. The same idea applies for a gun. Just because as you're rotating, you release the bullet right here, doesn't mean that the bullet's going to start curving that way. Instead, it's just going to go straight. They've proved this on multiple different reliable sources. One of them is in Mythbusters. And secondly, at one point in the movie, the main character actually curves the bullet like this. So not only does he curve it to the right, he also finds a way to curve it to the left, which is physically impossible. Second reason why it's wrong is in the last scene of the movie, Angelina Jolie shoots in a circle and kills 10 people with the same bullet. Every single one's a headshot. So there you're assuming that the bullet is traveling fast enough to continue its speed around an entire circle. Then you're also assuming that it can go through everyone's head, not losing any momentum, not dropping down due to gravity, just continuing the straight line with a perfect circle to also kill her. And that's wrong for at least one reason, which is here, this is called the Taylor KO factor. Basically, it's a mathematical approach for evaluating the stopping power, which is basically the penetration power of a bullet for hunting cartridges. Let's assume that the pistol that they had in the movie was a .45. According to the Taylor KO factor, if you take the mass of the bullet in grains, 1 pound is about 7,000 grains, and you take the velocity of the bullet in feet per second, and you take the diameter of the bullet, for a .45 it weighs 231.5 grains. It travels at approximately 836.61 feet per second, and it has a diameter of 0.452 feet. If you plug this into the formula for Taylor KO factor, you get about 12.5 Taylor KOs. That's about the same as saying 690 millimeters of penetration power. So basically, after the first head, the bullet's just going to drop straight to the ground. And for comparison, a .50 caliber bullet, which is about yay big compared to a .45, which would probably be like that, has a Taylor KO factor of 147, which is approximately 125 Taylor KO factor bigger than this. And that's, Alex, what I wanted is a totally fake
You
movie.
got me again.
The Fast and the Furious.
Well, the plan's working. You guys have every corrupt cop in Rio on your tail. You guys have to move fast.
What's the best route?
Okay, keep going straight another half mile until Rua Fonseca.
And then go left.
Spikes ahead, Don. We got spikes.
We're going right.
Nah, it's too tight. We're not gonna fit.
We got no choice now.
.43 kilograms, you can understand how much this safe weighs. Now, we next moved on to our free body diagram. In the free body diagram here, you see a safe, you see the mg, natural force, and then you see the friction pulling one way and the force of pull pulling the opposite way. So next we moved to actually calculating the force of friction. So what we did was we calculated the force of steel on concrete, and we got that the coefficient of friction is 0.45. And when we did the math, we got that the force applied by the friction is actually 200,034 newtons. We then moved on to calculate the force put by each car or the combined cars. And by using the 0 to 60 times that we researched online and using the basic formulas that we used in the beginning of the year, we calculated that each car puts out 12,275 newtons, which combined 24,550 newtons, which is actually 1/8 of the friction that is put by the safe and its weight and the coefficient of friction. Therefore, this math proves that the scene is completely impossible. It's also important to take into consideration that the cables would turn and would tangle. And then also, it's important to mention that when we did this problem, we assumed that the tires were some ideal super tire that would not skid at all. So all these units are assuming that the tires have zero skid.
DJ Steve.
Oh yeah, let's take a